Hi, in this video, we're going to be looking at problem 11 from Project Euler. I think it's a really interesting problem. It's the first problem in the problem list that I actually thought was kind of hard. So I want to record it. I'm going to be doing the solution in Rust, and I'll probably look at a few different solutions, starting with sort of the easiest or the most naive solution, then we'll build up to a more sophisticated program. I'm also learning Rust, so I'm going to be Googling a lot of things. I'm going to try not to use Claude too much. I've already gone ahead and copied the grid into a text file. So we have input underscore grid here. And just to start the program, we're going to get the file path. This is really important because in Rust or like any compiled language, when you have a file path, you need to be very careful about whether the file path is relative to where you're calling the program from, or where the source file is. So this makes sure that at compile time we're fetching the file relative to the actual cargo file. So this is the same directory as cargo.toml, and right next to it we have the input grid. Here we're constructing a path to it from the string that we constructed in line 6. And then this is just to test that it's working. So I'll do cargo run. We have some warnings, but we can see that it's printing out the actual grid. It's printing out the file path at least. So now let's see if we can open the file. So we don't need the display anymore, so I'll get rid of that. And let's say let file equal to file open. Path. Path is right. Okay, good. Now the issue is this is it's a result. So let's see. Let's just try to match it. Let's say match. Let's go here. Match this. And then the first case is if it's okay, match. Okay. Um, yeah, I'll need a Google file that open. Let's do that. Rust file open. Let's see. So you pass. Oh, okay. Okay. I think I'm confusing it. So, okay, I guess this needs to be mutable. That makes sense. And here we probably want. Okay. All right. So do okay file, and then in the error case we can do that. Oh, okay, and that's why they want the display. Okay, that makes sense. Okay, I'll bring the display back in. We'll just copy this whole thing. Um, okay. Um, let display equal path dot display. Now, what I don't understand here is why we need to pass a reference to the path and not just the path itself. So I'm gonna see if this runs first of all. It doesn't. Um, this needs to be path. I don't know what this is. Let's get rid of that. Okay, so it ran, and there's no print right now. But what happens if I change this to just regular old path? Still compiles. I really don't know. Okay. Well, if I understand, I'll explain it. Okay. I think it's just we don't need it. Like I think probably if we do it this way, we won't be able to access the path later on. So if I do try print line, I don't think this is going to run anyway. But let's see, because path isn't really a no path. Yeah, it's a path object. It's not a string. But um, yeah, that doesn't work. Um, I'm guessing this shouldn't work, but it does. Okay. This works the same. Yeah, they both work. I really don't know. But either way, I'm just going to copy what they have in the actual Rust tutorial. So now we have the file object. So I think we can, let's see if we can just go through the lines of the file. We can go file dot read. Let's see what that does. So here, read to string. S. I think we'll probably do read to string, and then we'll just dump the file into. It's not a very big file, so we'll just dump it into a string, and then we'll iterate through the string and try to form a vector of vectors. I think that's the approach I'll go right now. And we'll make the string mutable as well. Let mute s equal file dot to read to string. Do I need to provide a buffer? What happens if I don't pass one? Oh, okay. So you create a string s, and then we're going to write to that buffer. Okay, that makes sense. Let's copy this as well. Okay. So at this point, we have s, which we can now do s dot lines. Yeah, okay. So we'll do for line in s dot lines. Let's do print line. Okay, let's see if this works. Okay, so that's working. Let's see if let's do some more tests real quick. Let's do dot enumerate, and now we can get the index as well if we want. So we can do something like, I don't know, do something like this. I don't know if this works because I is unsized. Maybe it won't work. No, it works. Okay, good. Now we can see the index is indexing is also working. Is it printing more lines though than we want it to? Oh yeah, over here it's printing the whole contents. We don't want that. Let's remove. So just in the OK case, let's just say file contents are in S now. So we have that, and we'll do print line. We don't need this anymore. We don't need that either. All right, cool. Now our goal would be to take what we have in S and try to put it into a vector. So let's think that through a little bit. For sure, we might not need this loop anymore, but we'll see. We want we'll just say let grid be a vector of vectors of, let's see, these are all like, we're going to be multiplying them. So maybe their product could get, because we're going to be multiplying the elements. So maybe we'll want to do U64. All right. I'm just doing vec new. I hope this works. Maybe I do colon. Yeah. Okay. Okay, I think this works. Okay, good. And now, let's see. We can probably, do we have grid dot push? Yeah, we have a push. So we can push vectors into it. Okay. Maybe we'll want to loop through each line and push it, but we want to figure out how to turn each row into a vector. Let's see. Maybe we'll try to use the iterator tools. So we'll do, this is lines. So each line, we can map it. And each line is a string. So we'll need to use some string methods. So we'll call it, let's call it line. And we want to return s dot split. Okay, so maybe. Okay, so splitting is probably exactly what we want. We'll split. We'll split by the space is what we want. So we'll split. Okay, so now if we imagine we have the lines, each line gets split into a vector of strings. Well, not yet. We probably want to collect it. So let's try. Let's try here. Let's see what it's saying right now. Okay, so I just want to see this. This is an iterator. split split returns a split object. Okay. And then collect returns an iterator. Let's just do for each for now. Let's remove this part. Let's just go for each f. I want to see what's the type of f right now. F should be, f is an iterator of, okay, let's try print line. See if that works. Okay, it needs to know the type of f. I guess I'm not sure what type of f is. I feel like f should be a vector of strings. Does that work? Okay, let's try some. Let's be simpler. So we'll use a loop instead of like this one. We'll go let dot split. Line is a string. Oh, let's get rid of the enumerate. We don't need it anymore. Split. Okay, this is a split object, so we'll do collect. Now row is an iterator. Okay, so we'll call it, it's a vector of something. It's a vector of strings. Just gonna Google Rust open print vector. Okay, let's just do this. Just, yeah, I want to see if this compiles. Nope. Okay, of course, this is row. Okay, so that's not going to work either. It's got to be inside there. Let's just see if this works. I want to see if it's printing each row. It does. Okay, so now we're making some progress. And now each row is in this vector. Okay, and so I think we can do something like dot map, and then here we can go s dot parse Why doesn't this work? That doesn't work out. I think it's got to be like this. Okay. Still doesn't work. Okay. Like that. Okay. I don't know why I have to do into iter. I thought collect made it an iterator. Oh, okay, but I do another collect after the map. That makes sense. Okay, and then here, I don't know if it should be. Okay, parse as U64. Does that work? I gotta do. Okay, now it's working. And then I guess this is a vector of results? Okay, I don't know. Okay, let's see if we can print line the row again. Okay, that didn't work. Okay, so we need to unpack it somehow. I don't want all these okays. Let's just do unwrap here. Let's see. Okay, so now we have each row, it's a U64. So here, now we can go, we'll update this annotation because it can just be U64. I wonder if we can remove this annotation now and it'll work. Okay, and now we'll do grid dot push row. And then, okay, grid's got to be mutable. Okay, and then we'll do print line, and then we'll do comma grid, and let's see what's inside grid now. Okay, so grid is now a vector of vectors, so that's looking good. We can also, just for fun, put breakpoints and look at our program that way. I want to see if that works. Is it wrong? Yeah, okay. Cool. Yeah, so now look, when it's with the breakpoints, we can look at grid. And it is size 20 and full of vectors also of sign. Oh, okay. Error, invalid value object. Interesting. That's not good. Not sure what that means. Okay, well, whatever. We printed it, so I think it's working. Maybe I debugged an old version because we don't have the print anymore. Let's try debugging again then. So again, we'll put the breakpoint to debug. Yeah, so we have S, which is string. Oh, interesting. Oh, wait, I guess at the end of the program, we've already dropped okay, whatever. Okay, we can move on. This is, now that we have the grid, we need to start figuring out how to go through the grid and figuring out the highest, the maximum product of 4 elements. So it's a windowing problem, but in 2 dimensions. Let's think this through a little bit. So let's see how we're gonna. Well, okay, we'll keep the first solution really simple, and then we'll build up as we go through the video. So we'll do for I in, is it grid dot len. So I think we will 10 dot dot 0 dot dot. We can go, or we don't need to go. No, we do want the iterator because we're going to be playing around with those iterators a lot. So we can do print line grid I. We'll remove these breakpoints as well. And then I like running it in the command line. I've set this up so we can just press the run button as well. Builds. Okay. Cool. And here we'll go for J in 0 dot dot grid I dot len. We know it's 20 by 20, but we might as well just do this at runtime. Let's go. Let's see if we can go through the whole list. Oh, that's GitHub. Don't want that. Let's go cargo run. Oh, how am I here? Go cd problems, cd problem 11 cargo run. And okay, good. So it's going through each element. Okay, now I just want to think about how we're going to go about finding the product. We can go horizontally, we can go down, and we can go diagonal, and we can also go up. But of course, we need to do bounds checks at each time. So let's keep it simple. Let's just try find like going horizontal. Well, like we'll build up. So we'll just for each element, we want to go and check the product of it and the next three elements. And of course, we need to be careful about going out of bounds when we're adding. So yeah, let's let's not worry about the program being neat for now. Let's just think it through. So like we want to go right. Product of element and three elements to the right. Well, we can do something like grid I, j. Call it prod right is equal to grid ij times. So if we imagine we're going to the right, so I is the row number, j is the column number. So we want to increment, do j plus 1, and we'll do this, we'll call let j plus 1, and we'll do j plus 2. And we'll do j plus 3. Of course, the problem is out of bounds. So we should not do this operation if j plus 1 is greater than 19. But I just want to see what happens if you run this. I feel like it should crash. Yeah. Yeah, and we get an out of bounds error. So how is the best way? How's the best way to go about this? I think, again, keeping it simple, we'll just say if j plus 1 is greater than 20, greater than j plus 1 is equal, greater than 19, because j can be equal to 19 if j plus 1 is less than 9. Okay, no, that's not, we don't want that though. So, okay. If j plus 3 is, yeah, if j plus 3 is greater than 19, or j plus 3 must be less than or less than 20, we'll say. And now we can make it a little bit nicer. We can do this. Then we can and then here, I think I'll want product right to be available. Prod. Let prod right be unsigned 64 U64. Can I just declare it like this? Does this work? Yeah. Oh no, I gotta make it mutable, I guess. Do I have to make it mutable? I don't think so, because we're assigning it once. Let's just see if this runs. Okay, cool. This runs. Okay, and now we'll let mute max be U64. Let that equal to 0. Okay. And then if prod right greater than max equals prod right. Okay, and then y is possibly uninitialized. Oh, okay. I guess we'll make it equal to 0 here. Oh, okay. Now it's got to be mutable. Okay. Oh, okay, cool. And then we'll just at the bottom we'll do print line max. And doesn't work. Let's see. Okay, we'll do. Oh, I gotta put it in quotes. That's why. Also, for us to verify, we'll need to. That's a big number. So over here, it does tell us, but it doesn't tell us the max for any. I don't really know how we would verify that it's working at this point. Probably I do want to keep track. Like it'd be nice if we also save the index I and j for the max value, so that way I can just check the solution. So we'll let max coord. I'll do let mute max coordinate of max coord of max, and this I want it to be a tuple. I don't know how to define tuples. It's going to be of type unsized, and again, I guess we'll initialize it to be 0, 0, and then here we'll say this is equal to I, j, and why is this? Okay, cool. And we can go here, and we can print out the coordinates of max. Okay, let's see if this is working. 8 and 10. What is that? Why? So as row number 0, 1, 2, 3, 4, 5, 6, 7, 8. And that is going to 10 column 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's multiplying these numbers 78, 78, 96, 83. Let's see if the number matches at least. Go calculator. What was it? 78, 78. Let's go 78 times 78 times 96 times 83. Does that match what we have in our console? Let's hope so. It does. Okay. So at this point, I am going to say I think it is correctly figuring out the product to the right. Of course, we want to check multiple directions. So we've implemented going right. Now let's go down. Let's like pick a number like in the middle. So we can go to the right. We can go to the left. So let's do left. Let's do the same kind of block, but for the left direction. Let's do product left. Except now we're going to check if j minus 3. So we're going to the left, so we're going to go j minus 3. Oh, okay, wait a second. So j minus 3 has to be, it can't be a negative number. That's the thing. So the thing is j is unsized. So I don't know what happens when you subtract numbers from unsized if it wraps around or something. So that's something I don't know how Rust handles it. Probably what I'd want to do is I don't know how I'd find out. Like I want to put a breakpoint and just see what j minus 3 is. Or I'll Google. Handle u-sized negative numbers. Okay. So this is the minimum value. And then the issue is with the unsized. That's interesting. Not really sure how I'm going to check if it wraps around. Okay, so that's interesting. Oh, okay, I can do cast. I can cast it as an. I guess if we're going, we'll just keep it simple for now. If we're going left, we know that j must be greater or equal to 3. That's it. As long as we're in this column, which is j equals 3, we can go left. So I guess it's kind of like, instead of doing this, we'll just do j greater than or equal to 3, which means we're in the all right, so we'll do prod left. All right, and then we'll go, so this is always the same, but now we'll go j minus 1, j minus 2, j minus 3. Okay, so now I think we have left working. Let's see if this works. Still the same number, so that just means that there isn't any situation where going left is going to result in a bigger number than that going right, I suppose. obviously if we switch the order, we'll get the same number, but it'll be from like actually that'll be an interesting test. So I want to if I do the left check first, I'm expecting I'll get the same number, but I'm going to get a coordinate that's shifted to the right. So we would expect 8 comma 13 maybe or 14. Let's see. So we're going to do the left before we do the right. Let's run it. Oh, interesting. Hmm. I would have thought that would have worked. If I just comment out the right part, does that work? Now it works. Okay. And it is the same number. I'm just surprised that the order didn't make a difference. Oh, I guess because we get to that coordinate first, so it doesn't actually matter. Yeah, that makes sense. It doesn't matter the order because we get to 8 to 10 before we get to 8, 13. Okay, so we've done left and right now. And so now we just have to we gotta do down, and then we gotta do left diagonal, and we gotta do right diagonal. So let's, right, left, right. Oh, I closed it by accident. No, I didn't close it. Yeah, left, right, down, left diagonal, right down. We don't have to do up and up we don't have to do the up diagonals because um, it's duplicating the work if you think about it. In fact, I'm not even sure if we need to do left. If we're doing right, I feel like the left is redundant. Um, because yeah, anything we've done the right on, we don't need the left. So I'll comment that out. Um, so we just need to do right, down, left diagonal, right diagonal. We don't have to do left, up. Yeah, so four operations essentially. So we've done right, and I removed the left because we don't need it. And now let's do down. That's probably the next simple one. So for down, if you think about it, we just need to make sure that so like if you imagine, we can go down. This is the last row we can go down from. Everything after this, we can't go down. So we just need to make sure that I plus 1, 2, 3. Oh, we can go down from this row. I want to say I plus 3, which is the row number, cannot be bigger than the bound. So we'll do prod down. Okay. And we'll say if I plus 3. And now here, we don't want to check the row length. We'll go the grid length because grid is a vector of vectors. So that's 20. And then we'll keep the column number the same. And now we'll go I plus 1, I plus 2, and I plus 3. Okay. And so now we're going down. So now before I run it, I'll go ahead and try to implement the diagonals. The diagonals are a little bit more complicated, but not much more. So if you imagine, now let's do right diagonal prod. right diag. And here we have two conditions. So again, we can't go honestly, I'm not even sure if we need to do left diagonal. We'll see. But right diagonal for sure we need to do. And it's the same condition on I and j. So it's just I plus 3 has to be less than the grid length, and then j plus 3 has to be less than that as well. Do it and here it's the same j plus 1, j plus 2, j plus 3, j plus 3. Okay, I'll go product right diagonal. Okay. Why is this having troubles? It doesn't need to be mutable? Oh yeah, well, no, it does now. Okay. So we have right, down, right diagonal. And then I'm just thinking, do we need left diagonal? But if you think about these four, yeah, we do, because it's completely separate. Like just because so we'll need left diagonal as well. So left diagonal, again, we can't do it if the column is less than this number, and we can't do it if the row is over here. So like this is kind of the last. Our left diagonals can't go in this region here. Okay, so we'll kind of do this. Product left diag. And then let's see. So I has to be greater than 3. Essentially, it's the same thing here. Greater than or equal to, I guess. So I has to, right? No, that's not true. To go left diagonally down, it's actually the same thing as going right diagonal. This condition is the same. And it's the same condition as going down. Okay. The condition on this is different. This is the same condition as going left, which we don't have anymore, but this needs to be j needs to be greater than or equal to 3, I'm pretty sure. Okay. And so now here we're gonna go, so the i's it's still the same. It's the j's that we're gonna go j minus 1 here, j minus 2, j minus 3. Okay, and now let's see if it runs. Okay, so we have an overflow somewhere. Why? Let's see. I feel like if j is greater than or equal to 3, we have does it tell us which line number? 65, 58, 58. I think this means this is fine, I plus 3. I guess the length is 20, we want it to be 9. This is all probably wrong. But I'm doing strictly less than, so that's fine. How do we debug this, honestly? Let's run backtrace equals 1. Let's see what that does. Hmm. Let's just run it in debug mode and see if it tells us where the error is, where it's crashing. Nope. I guess it's 65. So this is, it's definitely like this is the problem, but it's the same as going, okay, I wonder, we deleted the left part, but we figured out, what was left? I feel like if J, I guess I'm saying J has to be greater than or equal to 3. That's what it is. Okay. So let's run this again. Okay. That's interesting. And then we don't know which direction we need to go to get this number. So maybe I should be storing the direction as well. Let mute direction equal spring new, maybe? Does that work? Okay. Yeah, does it like that? Okay, it doesn't like that. Maybe we should just make this an empty string. Does this work? Okay, let's see if we can. Let's see if this at least compiles. Okay, interesting. And it does seem to be, oh no, okay, cool. Now we can just go ahead and copy this into each part and go down. Let's go right diag, and let's go left diag down here. Okay, let's run it. Okay, so this probably works. At this point, like we've written a program that works and gets the answer, but like honestly, it's trash. I don't like it. So I think I'll probably pause the video here and I'll think about it some more and probably make another video where we write a much cleaner version that is more clever and doesn't have all this repetition and mutability. But at least at this point, we have a solution that works. I'm going to test if it works, and then I'll go ahead and see if I can write a better version of the program. Let's see. It's taking so long. Oh, okay. I got a interesting. Okay, so that definitely worked. Thank you for watching. And then in the next video, we'll write just a nicer solution, and then we'll compare the idea.